In this video, we're going to talk about how to solve linear inequalities using a graph. So first we need to know that if you have the xy coordinate system, then we know that the y goes up as we go up. So the y increases as we go up and it decreases as we go down. While for the x increases as we go to the right and it decreases as we go to the left. So let's say the question wants to answer something like this: y is greater than 2x plus 1, and at the same time the y is less than or equal to negative x plus 4. So in order to solve an inequality, you must sketch the line first. So let's sketch the line first. So we know that the y-intercept is at 1 and the slope is 2 for the first line. So as if it was equal. So slope of 2 meaning that if you go 1 in the x, y is going to increase by 2. So this is your line. And this is the line where y is exactly equal to 2x plus 1. For the other line, it has a y-intercept of 4. And the slope of negative 1, meaning that it's going down. So it's going to go down like that. And this is the equation y equal negative x plus 4. So this is always the first step, that you sketch both lines as if they were equal. Now, if you want the y to be greater than 2x plus 1, we know that y increases as I go up. So if all the points on this line are the points where the y is exactly equal to 2x plus 1, if I want it to be greater, it's as if I'm saying I want all the values above that line. I like crossing out all the values that I don't want. So if the y is greater, so it needs to be above this line, I cross out whatever is below this line, because these will represent all the points that the y is less than 2x plus 1. And in the same concept, if you go to the other line, here I have y less than negative x plus 4. So if this line is y exactly equal to negative x plus 4, I want it to be less than. Meaning that if this is my line, I want all the points below this line. So I cross out anything above the line. So I cross out this. So the answer at the end is going to be this region. This is the region that contain all the points that are above 2x plus 1, but at the same time they are below negative x plus 4. Let's try another example. If you have y less than 3x minus 1, and at the same time y is greater than or equal 2x plus 2. So we said that the first step is for you to always sketch both lines. So I'll start by doing the x, y coordinate system, and then the first line has a y-intercept at negative 1 and a slope of 3. So it's going to go up 3 like that. Rough sketch. So this is y equal 3x minus 1. For the other line, it has a y-intercept of 2, and it's going to have a slope of 2. So it's going to go up, but not as fast as the other line. So it's going to go up something like that. So this is my second line. These are my two lines. This is y equal to x plus 2, and the other line is y equal 3x minus 1. So for the first inequality, you want the y to be less than 3x minus 1. So if this is 3x minus 1, you want the y to be less, so you cross out whatever is above this line. So you cross out this. And for the second line, you want the y to be greater than 2x plus 2. This is 2x plus 2. You want the y to be greater than that, so you're going to take anything above the line, so you cross out whatever is below as well. So you'll end up with this region as your answer if the line goes up like that and like that. So y equal to 3x minus 1, you cross out whatever is above, and for the second line you cross out whatever is below, so the answer is going to be actually in this part between both lines. So the answer for these inequality are always going to be regions, they're not going to be points.